Welcome to the DIY Honda Garage channel. Welcome to the presentation on DTC P0710, which indicates an issue with the Continuously Variable Transmission (CVT) Fluid Temperature Sensor on a 2016 to 2021 Honda Civic. This DTC signifies that the voltage from the sensor is out of the specified range, leading to potential issues in transmission fluid temperature readings. As many know, proper fluid temperature is critical for optimal transmission performance and longevity. A malfunction in this sensor can lead to decreased efficiency, overheating, and eventual transmission failure if not addressed promptly. Our goal today is to walk through the troubleshooting processes to isolate and resolve this issue effectively. Let's dive into the details of this error code and the necessary steps to rectify it. The DTC P0710 signals a failure in the Continuously Variable Transmission (CVT Fluid Temperature Sensor, which is responsible for monitoring the temperature of the transmission fluid. This sensor plays a crucial role in ensuring that the transmission operates within optimal temperatures, preventing overheating and ensuring efficient performance. It is located within the transmission assembly, connecting to the Transmission Control Module, TCM, to relay temperature data. The reading from this sensor is vital for determining the proper operation of the transmission fluid and ultimately affects the overall vehicle performance. Understanding the role and position of this sensor is key to resolving the DTC effectively. The likely causes of DTC P0710 include various electrical circuit issues that prevent the proper communication of the fluid temperature sensor with the TCM. A faulty temperature sensor itself may not accurately relay temperature data. Additionally, wiring issues such as short circuits or broken connections can also lead to erroneous readings. A malfunction with the TCM can further complicate the diagnostics as it fails to interpret the signals correctly. A thorough examination of these components is essential in identifying the root cause of the DTC and ensuring proper functionality moving forward. Drivers experiencing DTC P0710 might notice warning lights illuminated on the dashboard, indicating a fault in the transmission system. Additionally, transmission performance may begin to suffer, manifesting in symptoms such as unusual or erratic shifting behavior. Drivers may also observe abnormal temperature readings for the transmission fluid, often correlating with operational inefficiency. Recognizing these symptoms not only assists in immediate identification of the issue, but also helps in avoiding further complications that could arise from continued driving with a malfunctioning transmission system. Prompt diagnosis and intervention are crucial for maintaining performance and preventing future damage. First, ensure the vehicle is turned to the on mode without starting the engine. Using the Honda Diagnostic System, HDS, check for any other pending or confirmed diagnostic trouble codes, DTCs, that may coincide with DTC P0710. Identifying additional DTCs is crucial because they can indicate related issues or provide context that aids in troubleshooting. Recording any other codes will assist in creating a comprehensive diagnostic path for addressing the problems at hand. If other DTCs are present, you'll want to follow their respective troubleshooting protocols. However, if none are found, proceed to Step 2 for further investigation into the specific parameters associated with the CVT Fluid Temperature Sensor. Next, check the parameters associated with the CVT Fluid Temperature Sensor using the HDS. You should specifically look for the voltage readings, which should fall within a certain threshold. The expected voltage should be between 0.05 to 0.09 volts, or 4.83 to 4.92 volts, depending on the current system condition. Matching these current conditions to the stated threshold allows you to determine whether the failure is consistent. If the voltage aligns with the lower range, 0.05 to 0.09 volts, it indicates the failure is duplicated, leading you to the next step. Alternatively, a reading in the higher range, 4.83 to 4.92 volts, will direct you to a different troubleshooting path, addressing any issues associated with that voltage level. For step 3, begin by turning the vehicle to the off-lock mode. Disconnect the solenoid wire harness A 8P connector before moving forward. Then, switch the vehicle back to the on mode and check the voltage reading from the CVT Fluid Temperature Sensor using the HDS. The reading should be less than 0.09 volts. If the current reading meets this criterion, it indicates that the temperature sensor is functioning correctly, and you can proceed to the next step. However, if the reading does not match this threshold, then the transmission fluid temperature sensor is deemed faulty, necessitating the replacement of the solenoid wire harness A, which contains the defective sensor. In step 4, once again, ensure the vehicle is in the off-lock mode. Next, disconnect the TCM50P connector. You will need to check for continuity between designated test points 1 and 2, specifically between TCM pin number 33 and body ground. The test conditions require that both the solenoid wire harness A 8P connector and TCM 50P connector remain disconnected. If continuity is found, it indicates a short circuit to ground exists in the transmission fluid temperature TATF wire between the solenoid wire harness A and the TCM. Repairing this wiring issue is critically important to restore correct sensor functionality. In the absence of continuity, it verifies that the TATF wire is intact, allowing you to explore other troubleshooting options. For step 5, switch the vehicle to the off-lock position and disconnect the solenoid wire harness A 8P connector. Here, you will be required to connect terminals A and B with a jumper wire, specifically connecting number 7, terminal A, to body ground, terminal B. Once this step is completed, turn the vehicle to the on mode and observe the readings from the HDS concerning the CVT Fluid Temperature Sensor voltage. You're looking for a reading of less than 0.07 volts to proceed positively. Finding this measurement confirms potential faults in the system and directs you to the subsequent troubleshooting step, while readings above this threshold will require investigation into alternative areas of malfunction. As we approach step 6, begin by turning off the vehicle and removing the jumper wire used in the previous step. Subsequently, reconnect the jumper wire from the solenoid wire harness A 8P connector, female terminals, number 6 to number 7. After confirming these connections, switch the vehicle back to the on mode and check the values of the CVT fluid temperature sensor again using the HDS. You will need the voltage reading to be less than 0.07 volts for successful diagnosis. If this condition is met, it indicates a faulty transmission fluid temperature sensor, which warrants the replacement of the solenoid wire harness A. Alternatively, if the voltage is adequate, you will need to investigate and repair any open wire issues in the SG5 wire that connects the solenoid wire harness A to the TCM. In the final troubleshooting step, ensure the vehicle is off, lock, and disconnect the TCM 50P connector. You will check for continuity between designated test points, specifically the solenoid wire harness A connector, female terminals, number 7, and TCM pin number 33. As before, these checks will confirm whether there's continuity in the wiring. If confirmed, it indicates the TATF wire is functional, prompting you to look for any relevant service information regarding other DTCs, or possibly substituting the TCN with a known good unit to check for changes in the DTC. If no continuity is found, repairs will need to be made to the open wires between the solenoid wire harness A and the TCM to ensure proper communication and functionality. Finally, to ensure that your repairs have addressed the underlying issue with DTC P0710, it is essential to verify all repairs made. Start by clearing any diagnostic trouble codes that were logged during the troubleshooting process. Following this, a thorough test drive of the vehicle is critical to ensure that it operates normally and that the DTC does not return. Pay attention to the shifting quality and fluid temperature readings during the test. Only once you confirm that no codes reappear and that the vehicle's performance is restored can you consider the repair process complete. This verification step ensures that the vehicle is in optimal condition and prevents recurrent issues. Engaging in preventive maintenance is essential to avoid future occurrences of DTC P0710. Regularly checking the wiring associated with the CVT Fluid Temperature Sensor can help identify potential issues before they escalate. Keeping an eye on fluid levels and quality is also vital, as low or degraded fluid can lead to inaccurate temperature readings and subsequent DTCs. Promptly replacing any faulty sensors as they are detected will keep the transmission operating within acceptable parameters. By employing these routine checks and procedures, owners can improve vehicle longevity and reliability significantly while minimizing the risk of costly repairs. To conclude, DTC P0710 suggests a malfunction in the CVT Fluid Temperature Sensor, primarily caused by electrical circuit-related issues rather than mechanical problems. Systematic troubleshooting will guide you through diagnosing the failure's core, whether it be the sensor itself, the wiring, or the transmission control module. By meticulously verifying each step and promptly addressing issues as they arise, we can ensure optimal transmission performance and longevity. Regular maintenance practices are equally important to prevent recurrence and protect the integrity of the vehicle's transmission system. Thank you for your attention, and I hope this session equips you with knowledge to diagnose and resolve DTC P0710 effectively. Please like and subscribe to the channel. See you next time.